All right, let's jump right into this explainer. Today, we're simulating a senior code review to really lock down why MISRA C standards are absolutely vital for writing safe, predictable, embedded software. Think of this as a hands-on tutorial. We're going to hunt down some common C language violations, look at perfectly compliant code, and most importantly, walk through exactly how to fix the errors that might be lurking in your current projects.
When you're mastering embedded systems, there's a clear progression. You start with basic C programming and microcontrollers, but preparing for real industry roles, that requires a massive shift in how you write code. It demands strict adherence to MISRA C standards, because let's face it, in the embedded world, a software crash isn't just an annoyance, it can be a catastrophic failure. MISRA is what guarantees that bulletproof reliability.
So here's our game plan for today's review. We'll quickly cover why MISRA C matters, move into naming and type rules, tackle safe expressions, dive into controlling the flow, handle functions and pointers, and wrap up with coding for the real world. Let's get to it.
Section 1. Why MISRA C matters. The literal foundation of reliable embedded code.
First things first, we need to understand how MISRA categorizes its standards. There are two main types you'll encounter. Required rules are exactly that, completely non-negotiable. If you violate a required rule, your code is simply not compliant. Period. Advisory rules, well, those are highly recommended best practices that you should normally follow. There might be some incredibly rare, heavily documented exceptions, but for this tutorial, we're treating both as our absolute gold standard.
Moving on to Section 2, Naming and Type Rules. It's all about establishing clear variables.
You know, standard C types like int or char are actually deeply ambiguous. Their actual size can change entirely depending on the compiler and the architecture you're using. That's why Rule 6.3 steps in. It forces us to use type defs that explicitly indicate both size and signedness. So, the fix for your codebase? Strip out those plain int declarations and swap them for precise types, like int16_t or uint8_t. It completely wipes out compiler-dependent guesswork.
Let's talk about array initialization. A classic violation is a flat, lazily initialized multidimensional array. Sure, it compiles, but it's risky. It's hard to read. Rule 9.2 mandates compliant structured bracing instead. The fix is that you must always use nested braces to explicitly match the structure of your data. A flat, non-zero array initialization is a major risk, and MISRA simply refuses to tolerate it.
Section 3. Safe expressions and initialization, where we avoid that dreaded, undefined behavior. Here is a notorious C language trap, using an assignment operator inside an expression that yields a Boolean value. Think about a standard if statement, where x equals y. Did the programmer actually mean to assign y to x, or did they just accidentally miss that second equal sign when trying to compare them? The compiler doesn't know, and MISRA won't accept the ambiguity. The fix is brilliantly simple. Just pull the assignment out of the if statement entirely, assign the value first on its own line, and then perform a clean, unambiguous comparison.
Now, if you've ever accidentally caused an infinite loop by altering your loop counter inside the loop body, maybe trying to skip a step, you will completely understand why Rule 13.6 exists. This required rule strictly forbids it. Modifying an iteration counter anywhere except in the loop declaration itself is a massive violation. How do we fix it? Use standard loop control features or auxiliary flags to manage your flow and leave that counter completely untouched within the body.
Section 4. Controlling the flow. Keeping our execution paths predictable. Ask yourself, what actually happens to your execution path when you omit a seemingly harmless curly brace? I mean, a lot of developers skip them for single-line statements just to save vertical space, right? But it's a really dangerous game. Because when a developer forgets those braces after an else statement, subsequent lines can drop completely out of that else scope. A variable assignment that was supposed to be conditional is suddenly executing unconditionally every single time. And yeah, that is almost certainly a bug. That's why Rule 14.9 mandates that every single if and else must be followed by a compound statement block. The fix? Never ever write naked if or else statements. Always use those curly braces, even for a single line of code.
All right, here is a rapid-fire list of entirely banned practices in MISRA C. Using trigraphs? Banned. They cause character confusion. The go-to and continue statements? They introduce chaotic, unpredictable control transfers. And recursive functions? They risk unpredictable stack overflows that resource-constrained embedded systems just cannot afford. The fix for all of these is to redesign your logic using standard predictable loops and linear top-down execution paths.
All right, Section 5, Functions and Pointers. This is all about handling memory securely.
Leaving empty parentheses in a function declaration is a pretty standard C habit, right? Well, it's a MISRA violation. Why? Because historically in C, an empty parameter list meant the function could take any number of arguments. That completely destroys type safety. To fix this and to make absolutely sure the compiler never makes assumptions, Rule 16.5 dictates we must explicitly declare empty parameter lists with the word void.
Let's talk memory. Manual pointer math, like adding arbitrary integers to a memory address, is a remarkably quick way to corrupt memory and crash your entire system. The crucial point here is that array indexing is the only MISRA-compliant way to traverse memory. So if you have code that increments a pointer using +5, fix that violation immediately. Rewrite it to use standard array index brackets.
Finally, Section 6, Coding for the Real World. Let's look at some final MISRA safeguards.
These structural rules are absolute lifesavers. First up, double-slash comments are a violation. We must only use /* block comments to ensure code isn't accidentally swallowed by weird line breaks. We also encapsulate all assembly language so it doesn't bleed into our C logic. And critically, for control flow, every else if chain must end with a final else, and every switch statement needs a default clause. The fix here is to always provide a guaranteed fallback path for your logic. Your program needs to know exactly what to do when unexpected data arrives.
And we absolutely have to prevent variable shadowing. If you declare a variable named I globally, and then declare another I inside a local function, you have created a violation. By forcing unique identifiers across all nested scopes, we fix the risk of accidentally modifying a global variable when we really only meant to update a local one.
So, knowing what you know now about undefined behavior, implicit types, and control flow risks, I have to ask, would your latest project pass a strict MISRA audit, or is there a catastrophic bug just waiting in your unbraced else statements? Take these fixes back to your codebase, apply the standards, and build the bulletproof embedded software the industry demands. Thanks for joining me for this explainer, and happy coding.